everyone. I hope everyone is excited to learn how to get started with Senseye Predictive Maintenance. As Disha said, I'm Liz McGinn, the demand generation lead here at Senseye in the Americas. I'm joined by Dr. Natalie Kurgan, the delivery training lead for Senseye Predictive Maintenance at Siemens. Today, we've pretty much be explaining Natalie's role with the help of companies, with helping companies get started with predictive maintenance. Before we get started, let's kind of go over our agenda. So we'll start with what is predictive maintenance, then we'll go into what is Senseye Predictive Maintenance, and then a little bit into our Senseye Knowledge Platform. But before we get started with Natalie's full job, Natalie, do you want to explain a little bit more about Senseye Predictive Maintenance?
Sure. Before we even talk about what Senseye is, I think we should cover a little bit about what is predictive maintenance first, because sometimes there can be some different definitions floating around. So let's just make sure we're on the same page. Now, the precursor to predictive maintenance is condition monitoring, which is using sensor data from machines to support decision-making in your maintenance journey. Condition-based maintenance builds on that and uses the data that you're collecting to replace planned maintenance. Predictive maintenance furthers that more by using online monitoring, so you can monitor thousands of machines rather than having a single person analyzing data. And the difference as well is that predictive maintenance is going to be using AI and machine learning, different programs, to see how data is trending rather than just telling you right when a machine is experiencing a degradation or a failure. Something like Senseye would tell you when it's on its way towards experiencing a degradation. So this way it can minimize disruption to your operations and to your maintenance by making sure you have everything you need to perform maintenance and to even know if your machine will make it to the next planned maintenance event. So let's get into what is Senseye. Now, even though predictive maintenance is in Senseye's name, it's important to not mix up and conflate Senseye with being predictive maintenance. Predictive maintenance is a strategy. Senseye is a tool to help a customer achieve that strategy. So what it's doing is it's using asset intelligence to help increase efficiency, essentially. I like to say that one. It helps increase uptime of your machines. It reduces planned and reactive maintenance, which reduces costs, supports remote work, and increases sustainability. So let's just get into how it works a little bit before we get into how we onboard and start somebody with using a technology like Senseye. So this is sort of the roadmap of what Senseye is. I have this laser turned on. I'm going to turn that off so I can click and you don't get distracted. So the way Senseye works is the first thing that happens is we have to take data from your machines. Now, this could include sensor data that is coming directly from the machine itself while it's running. It can include information from the PLC, like control signals. And it can also include information from maintenance. So as you're interacting with the machine, if there are hands on the machine, you're going to want to tell that information to Senseye so that it knows to see changes in the data. All of this comes into our cloud-based application, and it's fed into our pattern engines. So the pattern engines are, I would say, half of the AI and the magic of Senseye. I kind of hesitate to use that word because there's a lot of logic that goes into it. So the pattern engines take all of the data that you're feeding in. They establish what a normal baseline looks like for your data. And it takes minimum 2 days to do that for some of our more basic patterns. So they establish what a normal sort of fingerprint looks like. And then as your data, as it moves forward in time, deviates from that fingerprint, the app will generate patterns to categorize those changes in behavior. So these pattern engines can run automatically with no additional input, but you can also feed in, if you've seen failures in the past that are consistent and you have the right data for them, you can feed that in to match to them in the future. And you can feed in expert knowledge as well, additional information, whatever else you know about this machine and how it fails and how it looks in the data, you can give that all to the system in various ways. So coming out from the pattern engines are all these different types of potential patterns that can be detected. I'll show a couple examples of the most, default ones. So the top is anomaly. Now, anomaly is a short-term, short duration change, such as a step change or a spike or a burst of spikes like what we're seeing here. The next one is a trend, which is a long-term baseline shift in the data. It can be going up or down. Those two are the ones that are going to be run automatically out of the box. You feed your data into Senseye, it automatically starts looking for these with no configuration. The caveat is you've got to be providing the app with condition indicator data, which we work with our customers to help derive those and figure out how to do that. What a condition indicator is, it's data that in normal operation of the machine, this is oversimplified, but in normal operation of the machine, the data is steady. And when the machine is in a state of degradation or failure, it's not steady. It's doing something different. So a change in the data represents a change in the condition of the machine. So we help our customers to derive those and make sure we're feeding that into the system in order to get these anomalies and trends. The other most basic type of pattern that we detect does require some expert knowledge, which would be a threshold. So if you see this gray line going across here, I'm not sure how easy that is to see. That indicates sort of like an alarm level. If your data crosses a threshold, you will get a notification every time. You only get one for as long as it's violating the threshold. So what we see here in green is basically the notification that you would be given for that duration of time. We do have a bunch of other patterns that we can detect. Another one related to threshold, I don't have another image, but it's called a forecast, where you can enable an alert to be given to you if your data starts trending towards a threshold. And it will tell you approximately how much time you have until it gets to the threshold, depending on whether or not you're interacting with the machine to get it to go away again. So those are four basic types of patterns that are detected. Now, aside from thresholds, when an anomaly or a trend is detected, you don't necessarily automatically get a notification, which in Senseye we call a case. Instead, all of this pattern information is fed into our attention engine. So this information comes in here along with configurations such as asset criticality. So if you set an asset as being highly critical, you'll get a case a lot sooner than an asset that you set as low criticality. There's additional configuration we can do as well. So all of that comes in, and if it's determined that the change in your asset is critical enough, it will raise a case over here. This case opening is dependent on a value of attention index, which is just a value of how severe the change in the asset is, how much it needs your attention. Each case will come along with evidence, which is basically just a chart of the data that has a pattern on it. So you can review the evidence and provide feedback in the form of case evidence and case closure, and even in just interacting with someone like me who can go in and tune the pattern engines and the attention engine to improve detections in the future. I forgot to click, sorry. Hopefully that all makes sense. That's a kind of oversimplification of what's going on here, but I think it's a pretty good roadmap. Okay. There's no questions, right, Liz?
Nope, no questions so far.
Okie doke, thanks. In that case, if you have any questions on how it works, drop them in the questions chat and we can get to them in a bit. Otherwise, let's just get into our process. Now, a tool like Senseye, we want to take a lot of care when we onboard a customer with Senseye, because how well we onboard can affect the amount of success that we have. So we have something called the Senseye Knowledge Platform, and this was built by us using our best practices that we've developed over years of doing these deployments. It has 5 phases: scope, design, deploy, operate, and refine. Scope is pretty much everything that's done prior to a project charter. So that's before someone like me would get involved. That's done to figure out, what assets are involved, what sort of benefits might a customer have. And as soon as the project charter is signed, someone like me in delivery will come in and start designing the project. Okay, so design phase is exactly what it sounds like. We will do a number of asset discovery sessions to figure out what are your assets. A lot of times we have to talk with customers to figure out what do you define as an asset and what do we define as an asset and how can we sort of consolidate those two. We'll talk about what data you have available, how do they fail, what are the pain points that you have with these assets and how best can we configure them in the app to get you the results that you're looking for. As we're doing these asset discovery sessions, we're also having integration discussions to figure out how are you going to get your data to us. Deploy phase is all about getting things in the app, get the customer account configured, start getting data in, configure the assets, and do training. Operate phase is just using the app. That is your regular daily use. And we have different things to help with that. And we also help with case review sessions as we go. I think one of the really important things to note about Senseye is that we don't just hand you the app in these steps here and say, all right, see you, good luck, figure it out yourself. We work with our customers forever and help them with their case reviews, help, get feedback. What do you like? What do you not like? How is this working? How can we improve it? And that feeds into refine phase, which is when the account relationship is in the hands of a customer success manager. And really, it continues the process. It's really cyclical. So you might go back to redesign some assets if they're not performing very well. You might scale and add on more assets and have those sorts of discussions. So this is sort of an example of what a project deployment could look like. Again, I'm not going to read all this again because I kind of went over that. But I want to draw your attention to the timeline here with all these little cyclical aspects because it's not linear and it's kind of really hard to represent that. And each of the steps that we have for design, deploy, operate, and refine, we just use as needed. So there's a step in deploy, for instance, for procuring sensors. Well, if a customer already has sensors, we're not going to do that step, right? So this deployment plan is really made custom per customer as we start working with them. So you'll notice here that right when the kickoff meeting happens, that is when delivery gets involved. And we start setting up a timeline. What do we do next? Who are people involved? And then we start getting assets onboarded. And even as we're onboarding assets, we might still be going through the design phase of other assets. As we're working and operate with some, we may still be deploying some others. So it's very, very cyclical until we get into sort of a steady state period in which we would just be doing sort of periodic check-ins. Customers don't need us so much, but we are there when they do need us. All right, Liz.
Awesome. So that'll pull us into our first poll. So our poll question, we'll ask it so everyone can answer. Natalie will go into a little bit more, and then we'll come back to the answer. So if you only had 50 assets you could onboard into Senseye, what would you choose? The complex assets that cause the most issues and downtime, simpler assets of the same type, simpler assets of different types, or assets that are interesting to end users regardless of the type? And while you guys are answering that, Natalie will go into the design phase.
Yes, ma'am. All right, so take your time with that. We will get to your answers in just a minute as we pull up our description of what we consider design phase. So design phase consists of 4 steps. And again, they might not happen in this order. I'm working with a new customer right now. We are doing machine selection, failure mode, and data selection as one piece. And data architecture is happening in parallel with another group of people. So just as an example of how we might custom deliver a project. So the whole point of design is to choose what assets we want to onboard, understand their failure modes, understand how their data relates to those failure modes, and figure out how we're going to configure it in the app. It might require filtering the data. It might require transformations, which we can do in-app. And from there, we decide how we want to integrate, really how the customer wants to integrate. And very importantly, we determine success criteria. We want to do this early on so that we don't get to, renewal a year later and, they're not sure if they've had success or not. So we start that early on to make sure that we know what we're looking out for. In design phase, typically the people involved would be the machine experts, because we need to talk to somebody who knows the machines and knows what the data might look like for them. And so we can really work together to figure out how to monitor them. And the Siemens delivery team. I will say in design, I don't want to confuse anyone and have them thinking that we are building custom models per asset. The AI and machine learning builds the model. It does it on its own. All we are trying to figure out is what is the condition indicator. And for instance, if you're onboarding, let's say vibration data, okay, it's a very common condition indicator, but as it is coming straight from the machine, it might not be a condition indicator because it might be including data when the machine is off. So the first easy step is, okay, remove data when the machine is off so we can filter that out and be providing a steady signal that's not dropping all over the place. The other thing to consider with vibration is it dependent on any external factors? If you have a motor running in a VFD, every time your speed changes, your vibration is going to change, but it doesn't necessarily indicate failure. So we can set up that correlation in the app between speed and vibration. That's what we're talking about, rather than actually going in and configuring the actual algorithms that are looking for patterns. We just try to drive condition indicators early on. Liz, do you want to read the results of the poll? Or do we want to give it a minute?
Oh, nope, it's up. So the audience has chosen the complex assets that cause the most issues and downtime as the choice for the 50 assets. What do you think about that, Natalie?
Okay, I think that's a really common route that our customers usually want to go down. And we actually try to steer them away from that. Those most problematic assets are not the best choice usually for two reasons. Number one, if they're really problematic, they're probably being monitored really heavily already. So what value is Senseye going to show? It might just prove that it works, but we know it works. So it might not be actually adding much value because you're already monitoring it. The other reason we wouldn't want to start with that one is because it might be a very complex asset. And in the very beginning, we are coming from very separate spheres of knowledge. I know the app really, really well, but I don't know anything about your machines. You know your machines really, really well, but you don't know anything about the app. At some point, we have to kind of learn about each other. And once you kind of know what the app needs to look like, what it needs to see in the data to be successful, then we can really work together a lot better to derive those condition indicators. So we would usually recommend, let's start with simpler assets that are more basic. And honestly, if you start with simpler assets of the same type, get them all in the app, get them generating value while we then go back and revisit your more complex assets. So the app is working for you while we try to figure out those condition indicators. Does that make sense?
That makes great sense. Could you explain a little bit on what is an asset? Because I know you spoke about it, that we have two different definitions usually from our customers. So maybe it's best to kind of explain what an asset is in our eyes.
I'm really glad you reminded me to do that. So an asset, according to Senseye, is the smallest replaceable unit of a machine that has data. It's the thing that you're maintaining. You don't want to have some big, let's say you have something that you call a fan. And you say, all right, I want to get this fan into the app. But actually what you're calling a fan is a motor, a gearbox, and an impeller. To us, that's three assets. If you have data specifically on the motor and specifically on the gearbox and the impeller, that is three assets. And we should monitor them separately so you're getting cases that point you to exactly where the problem is. Also, when you split them up, driving condition indicators can be a little bit simpler than for a larger machine that might be more heavily influenced by process variables. Not always the case. So that's what we would consider to be an asset. I would also say from that poll, while we do tend to start with simpler assets of the same type, Senseye works great in bulk. So if you want to onboard 1 motor or 100 motors, to me, it's the same amount of work. So I would just say get 100 of those in. It's the same amount of configuration if they're basically the same thing. Get 100 of those in, get them generating value. Let's go back and look at the more complex ones once that's done. But the other thing that's important not to overlook is to consider assets that are actually interesting to the end users, regardless of type. We want a balance. Whoever's using Senseye should care about what's in there. So we try to balance the two. So I would say that's one of the main roadblocks, is just what assets to pick. If we go the wrong route, it can really influence the success of the project. And we've done this so many times that we kind of know, let's start with the simple ones that you have many of, and a few that are interesting to the end users if they're not the same. And let's go that route. The other roadblock is that the integration design is always the blocker. If there's a blocker, it's the integration. So it's important to choose, a partner to do that that has a lot of experience. So we often help with the integration design. We have a full developer documentation website that has all the information that's needed. And if we have more questions on that, just pop them in the chat. And that's kind of a complicated one, but we might be able to follow up with you outside of the webinar. Okie doke.
Awesome. So we'll go into poll number 2. What is the biggest cause of data quality issues? Sampling frequency, sensor placement, lack of contextual data, or noise in the data? Before we answer that question, we'll go into our next phase.
All right, so the second phase, once we start discussing our assets and getting data into the app, that kicks off deploy. So in this phase, if we need to install sensors, we do. Oh, I'm sorry, you're not seeing my mouse. Wrong screen. There we are. So we can install sensors if needed. We can help with that, point you in the right direction. The next step is to pre-process the data. Now that's it's almost a misnomer. You can do it on your side before the data gets to us. You can do it in an edge device. You can do it in 100 different ways, but you can also do it in the app itself after the data comes in. So we work with you to figure out what's the best way to do that. And again, that pre-process word, that just means remove the off states. Try to isolate a single state in the data, basically create a condition indicator. Get it coming in. Onboard, create the hierarchy, create your assets, configure them, change the criticality. We do all this stuff and we discuss while we do it. And then finally, we pretty much kick off with training. So we train the end users, we get them in, ready to go. Usually we wait a couple weeks in between, these two, because we don't want users coming in while in the beginning, there's going to be some false positives as the app is learning. It's absolutely normal. Sometimes the users will have never even seen their data before if it's new sensors. So we want to give the app some time to learn and start giving good cases before we get the users trained and in so they don't become disillusioned. Okay, so that is what is deploy. Who's involved? IT, integration team, and the Senseye delivery team, as well as possibly machine experts. We usually have somebody nominated on the customer side that we call a PDM champion. And that's the person kind of connecting us to everyone who needs to be connected. They're involved in everything. And they might be the first end user, the sort of power user. Not always the case, but that's often what we see. So Liz, if you want to read the poll results. If there are poll results. Liz, are you there?
Sorry. The audience thinks that the lack of contextual data is the biggest cause of data quality issues. Is that correct?
Oh, this was a trick question because whatever you say is correct, that's correct for you. They can all be problematic. I'm just going to go back just to see that list again. Sampling frequency, I don't know, if you're taking a data point once a day, that might not be enough, right? Kind of need continuous monitoring in place to really be able to fully utilize Senseye. Sensor placement, if they're not placed well or if they're placed inconsistently, that could be a problem. Lack of contextual data doesn't allow us often to isolate a state in the data. If your data is influenced by outside factors, you want to be able to account for that in the processing, so that you're not being told for temperature on a bearing, for instance, that your bearing is in trouble, but really just it's getting hotter outside. So if you're monitoring temperatures, as an example, you probably want to have ambient temperature as well. Noise in the data, that can actually be a product of even sensor placement and lack of contextual data. But again, Senseye is an incredible tool, but if you feed it terrible quality data, it's not going to give you the best results. So that's definitely something to keep in mind. Okay, operate. So operate really just becomes sort of the steady state, regular use of the app. And again, we might be in operate for some assets and design or deploy in other assets. So the important part in operate is we're monitoring cases. And what someone like me would be trying to glean from the user is, what is interesting to you? What do you want to see? If this case is interesting to you, tell us why. We can help to make sure, we can tune the algorithms, we can change configuration to make sure you keep seeing more of these and less of other things. If the results you're getting are not interesting to you, we need to know exactly why. Are you not interested when vibration is decreasing? Probably not. But tell us that, and we can help give feedback into the app to make sure that it doesn't tell you about things that you're not interested in. That sounds really straightforward, but sometimes if we don't have the right people in the room, which is one of our common roadblocks in operate phase, they don't know what's interesting to them. They might look at a case and say, well, yeah, that data changed, but I don't know what it means. So I'm just going to close it with, really not helpful feedback. That I would say is, these are all three kind of lumped into the same thing. This is one of the biggest factors to a project being successful or not. The app can't use itself. Like I said in the beginning, predictive maintenance is a strategy. Senseye is a tool. Somebody has to use it. So if we don't have the right people in the room to kind of go into these cases and figure out what's happening and what does the data mean for the state of the machine. And if they don't even have the pull to tell somebody, hey, you go take a reading on that machine. Hey, you go replace this on that other machine. If they don't have that sort of hierarchy in place, there's not so much value that they can get. So we want to make sure we have the right people in the room who understand what is interesting or not to them in the app, because if they don't know, then they're not going to get value. And if they don't get value, their buy-in and their involvement is just going to fizzle right out. And it's not reflective on the tool, but it can seem that way. So that's something that we try to establish early on, is make sure we get the right people, make sure we get them up and educated with Senseye, how it works, what they want to see. And again, starting with simple machines affects this. If you start with the most complex machine, they might say, yeah, it looks interesting, but I don't know what the heck it means. We've seen that before. So those are definitely things to keep in mind. Okay, refine phase. At this point in a deployment, this is usually when a customer success manager would come in and kind of replace my role, or someone like me in the delivery team. This is when we might go into each asset type, not asset, but asset type. So look at all the motors. How are they performing? How is the case feedback for motors? Is it good, or is it kind of on the lower side? If it's not very good, we're going to go back and revisit those in those kind of design phase steps and figure out how can we improve it. Do they need more sensing? If they need more sensing, then we'll step into deploy for that asset and get more sensors involved. And the whole thing we're trying to do in refine is just improve results. Improvements can always be made. It might involve scaling the deployment, going to new sites, getting new assets in. We also capture success cases and document them. We may develop additional integrations, such as integrating with a CMMS system, a maintenance management system, something like that. That would also help the results you see in Senseye. Involved here is everybody, depending on what you want to do, right? So it's kind of hard to say who exactly needs to be involved, but there should be a steering committee here to determine what do we do next. And as needed, you can get your machine experts, your end users, and your champion involved. The common roadblocks that we see, this isn't just for Refine, it can be throughout the full deployment, is a lack of high-level support. Really, for the most successful projects we've seen, there is a desire from the very bottom, from the maintenance, from the end users. They want Senseye because they want to become more efficient, because they're struggling to make meet all the demands that they have in their day. But we also need to see high-level support from the top down, making sure Senseye is an integrated part of the predictive maintenance strategy, and not just another tool, just like, oh, hey, go use this, but we're not going to tell you how your workflow should change, right? So we need it from the top and the bottom, and those typically lead to our most successful deployments.
Perfect. As you can see, we do offer a lot of support throughout the whole process, which is one of the great things about choosing us as a partner. As you can see here, you can keep learning by scanning this QR code, or contact us directly, or figure out your ROI potential with our ROI calculator. And yeah, so now we're going to go into, I think we have a little bit of time left to go into some questions. I know that we had some from the audience here. So one of the questions that came through is, they would like to know, how effective is Senseye's diagnosis? Do we have any individual metrics for each asset? And how can we define a level of assertiveness in the relation to the assets?
Okay, that's a great question. My answer is going to be really ambiguous. It absolutely depends. The better quality of condition indicators that you send to Senseye, the better quality of the diagnoses you're going to get. We do have, which I didn't really cover in here, we have this awesome Senseye Copilot, which as patterns are being developed and captured on different data on your assets, it's going to look at not just that asset, but all other assets of the same type, and see, hey, have we seen similar cases before? Did they have work events on them? Did somebody put a note in and explain what happened? What case feedback was given for those? It's going to look at all that and give you kind of a summary with possible explanations of what it thinks might be going on. So the quality of that possible explanation is completely dependent on the quality of feedback you're giving to the app. I will say we have customers who at this point don't do any maintenance on the machines that Senseye is monitoring unless Senseye tells them to. So that's a sort of level of success that you can achieve. There's also a creativity aspect involved. I have some customers that are so clever in thinking outside the box because they don't have a ton of data. So they're thinking, how can we leverage this process data that we have? And how can we leverage this and that? They've had huge successes, I mean, in the millions of dollars in downtime saved. Just by monitoring like the level in I think they had an oil reservoir and they're monitoring the level of it. They had a threshold with the forecast, and the forecast said, hey, you have 2 weeks until your oil drops below this level. So they save somebody around, they don't have to go by and collect information anymore on that piece of equipment. So it's also dependent on how you define success. How do you define success when it's in terms of efficiency? What about safety? If we're preventing emergency kind of downtime events, how do you quantify that? That's something that's tricky to do, but we do work with our customers to define those success criteria so that they can see how well they're doing. Hopefully that kind of answers the question.
Awesome. We got another one. Can you explain how Senseye becomes part of existing workflows with CMMS integrations and so forth?
Sure. So it's really up to the customer, but we can help. So Senseye does have capabilities to send information out. So if a case is opened up and somebody looks at it and says, yeah, I want a maintenance event done on this machine, an integration can be developed so that they tick a little button in the case itself in the app, and it sends a notification that will be picked up in the CMMS to create a work event. And then you can also go the other way, such that when that work event is finished and closed out, it sends it back into Senseye as a little work event, which can then be read by Copilot. So that's one possible integration. The way that we usually see people using the app day to day is they'll have like a core group of people, maybe they're reliability engineers, maybe they're maintainers, and they start each morning at a round table sort of situation, 20, 30 minutes, just to make a plan for the day. They'll check Senseye, see what Senseye is saying they should be paying attention to. That's the whole point of Senseye, is that you don't have to go looking through the data of all your thousands of machines all the time. Senseye is going to tell you what's changing and what you should really be paying attention to so you can prioritize your actions. So they'll use Senseye in that way to kind of prioritize their work for the day or the week. They might use it to even influence what operations are doing. If they notice Senseye is telling them that they're getting really low flow through a pump and it's going to cause the pump to cavitate, they might go back and say, hey, operations, increase the flow through that pump so our pump doesn't, die. That's another way that they might use it. The other thing too is, depending on how crafty you are with your integration or who you partner with to build these, you can choose to pretty much anything you see in the app, as far as like we have KPIs in there that you can document and track. It can be pulled out via GraphQL. So if you want to build another dashboard somewhere that's taking stuff from Senseye, that's taking stuff from some, oil analysis program you might have, you can take all that and collate it together into one little dashboard. We have folks that do that as well.
Awesome. We've got another question. Senseye seems like a useful tool for in-house machinery. Would it work well for an OEM that wants to monitor machines that have been installed at customer sites? Or would the customer of the OEM need to deploy Senseye directly to do their own monitoring?
That's a really good question. That might be a better question for our sales team. I know we've explored that option before, but as part of delivery, I personally haven't done that type of project. Not saying it's not possible. I think depending on the sensing on the machine, you might just need to install like a gateway or something to send it straight to Senseye. Usually we pull data, or data is pushed to us from a customer's historian, but that's not the only way to get data. So I think that would be the only constraint to figure out, and I'm certain that there's a solution for that. I would say see if we can get in touch with the sales team to figure out the details of that one.
Perfect. We got time for, I think, maybe one more question. New technologies are often introduced with a top-down approach where management tells employees to use them. This can lead to employees setting up new tech and then forgetting about it. What are some best practices to get end users buy-in and actively use the new technology?
Yeah, we see that problem a lot. Part of design phase includes working with the people at the top. Might be a steering committee, might be a champion, whoever is implementing Senseye. We have this presentation that we fill out that says, really, it's meant to facilitate a conversation between those higher ups and the people that are having to now use the software, so that they can be on the same page. And we just want to make sure that the people, the end users, are heard, because we know that there's a shortage in personnel. We know that they're being made to do like more than they have time to do. And learning another tool is not on their list of things that they want to do right now. But the whole point of Senseye is to help them with that workload, help make them more efficient. So we have a whole presentation that we do to try and facilitate that. Our case review calls that are weekly in the beginning, at least, also I think help, because it is the end users working directly with us. And we do try to help them see the value in the app. And we do listen to them so that we can understand from them what would be valuable. So we do try, but I think in order for it to be the most successful, people just need to talk to each other and listen to each other. When things come just from high up saying, you're going to use this now, and then they don't help them actually integrate it, that can be problematic. We try to help with that. That is a tricky part.
I agree. So anyway, thank you all for your time today, for joining us. I hope you enjoyed learning about our process and how we help you through rather than just handing you a technology and running away. If you want someone to contact you, please provide your contact information. Someone will reach out as soon as possible. And if there's any other questions, we'll be able to answer afterwards in a follow-up email.
All right. Thanks, everyone. Thanks, Liz.
Thank you. Look out for upcoming webinars as well.